Virtual memory. Here is your same structured beginner-friendly content for virtual memory, intermediate level, understanding memory management. Introduction. Modern applications require more memory than what is physically available in RAM. To solve this limitation, operating systems use a technique called virtual memory. Virtual memory allows a computer to run large applications, handle multiple programs at once, extend memory using storage, SSD, HDD. At the intermediate level, understanding virtual memory means learning how RAM and storage work together, how memory is managed efficiently, why systems slow down when RAM is full. Virtual memory is a key concept in operating systems and computer performance. What is virtual memory? Virtual memory is a technique where part of the storage, disk, is used as an extension of RAM. In simple terms, virtual memory using disk space as extra RAM. Example concept. RAM full means system uses disk as memory. Why virtual memory is needed. RAM is limited in size. Example concept. Multiple programs means more memory needed, means RAM becomes full. Without virtual memory, programs would crash when RAM is full, multitasking would be limited. Virtual memory allows systems to continue running even when RAM is exhausted. How virtual memory works. When RAM becomes full, the operating system moves some data from RAM to disk. RAM, disk, virtual memory. RAM, disk, virtual memory. Step-by-step process. Programs load into RAM. RAM becomes full. OS moves less used data to disk. Frees up RAM for active processes. When needed, data is moved back to RAM. Paging. Core concept. Virtual memory works using paging. Memory is divided into small fixed-size blocks, called pages. Example concept. Memory means divided into pages, means managed efficiently, key terms page. A fixed-size block of memory. Frame. A block in physical RAM. Page table. A mapping between virtual memory and physical memory. Example concept. Virtual address means page table, means physical address. Virtual address versus physical address. Programs use virtual addresses, not real physical memory locations. Virtual address means page table, means physical address. Virtual address means page table, means physical address. This abstraction allows better memory management, process isolation, efficient multitasking, swap space, disk memory. The disk space used for virtual memory is called swap space, Linux, page file, Windows. Example concept. RAM overflow means swap space used, page fault. Important concept. A page fault occurs when required data is not in RAM. Example concept. CPU request data means not in RAM, means load from disk. Types of page faults, minor page fault. Data is already in memory, but not mapped. Major page fault. Data must be loaded from disk, slow. Why virtual memory is slower. Disk storage is much slower than RAM. Example concept. RAM access means fast. Disk access means slow. When virtual memory is heavily used, system becomes slow, programs lag, disk usage increases, thrashing, performance issue. Thrashing happens when the system constantly moves data between RAM and disk. Example concept. Too many page swaps means system slowdown. Advantages of virtual memory. Virtual memory provides several benefits. Advantages include allows large programs to run, enables multitasking, improves memory utilization, provides process isolation, prevents crashes due to low RAM. Example concept. Virtual memory means flexible system usage, limitations of virtual memory. Despite its benefits, virtual memory has drawbacks. Challenges include slower than RAM-heavy disk usage can cause system lag. Excessive swapping reduces performance. Example concept. More virtual memory use means slower performance. Real-world example. Opening many applications. Open apps means RAM fills, means OS moves unused apps to disk, means active apps run. When you return to an app. It may reload from disk, slight delay occurs. Virtual memory versus RAM. Feature RAM, virtual memory speed. Very fast, slow. Location, physical memory. Disk usage, active programs, overflow memory. Volatility, volatile, persistent. Disk. Tips include: increase RAM. Use SSD instead of HDD. Close unused applications. Optimize system settings. Example concept. More RAM means less swapping, means faster system. Concepts learned. KEK. What virtual memory is? KEK. How paging works? KEK. Virtual versus physical addresses. KEK. Page faults explained. KEK. Why swapping affects performance. Simple definition. Virtual memory. A memory management technique that uses disk space to extend RAM and allow programs to run even when physical memory is full. Final summary. Virtual memory allows a computer to use disk space as an extension of RAM, enabling it to run more applications than physical memory alone would allow. It works through paging, where memory is divided into blocks and managed efficiently using page tables. While virtual memory improves flexibility and multitasking, it is slower than RAM and can reduce performance if heavily used. Understanding virtual memory is essential for learning operating systems, memory management, and system performance optimization.